This video is just to help you with the holiday prep on the chi-squared test that you've now received on Google Classroom. Can you please make sure that you've got your textbook with you, open at page 386, 387, and I'll just go through the process. The chi-squared test is basically a mechanism to allow you to decide whether a genetic result that you've got is within the normal range that you would expect, 9:3 to 3:1 ratio or 3:1 ratio depending. Rather in the same way that when you toss a coin, you could expect 50% of the time it's heads and 50% of the time it's tails, but you wouldn't be particularly shocked or worried if there was, let's say, 54 heads and 46 tails. Genetics is exactly the same. When you look at a monohybrid cross, you expect a 3:1 ratio. So for every 4 offspring, you'd expect 3 of them to show the dominant phenotype and 1 the recessive phenotype. And the same with the 9:3 to 3:1 ratio for the dihybrid cross. You expect 9 of them to show both the dominant phenotypes, 3 to show just 1 of the dominant phenotypes, 3 to show the other one of the dominant phenotypes, and 1 only to show both the recessive characteristics. But this is just like tossing a coin. It might not necessarily be exactly right. You don't necessarily always find exactly 3:1 or exactly 9:3 to 3:1. And the purpose of the chi-squared test is to decide whether any difference that you do find is significant. Is there a possibility that it happened purely by chance, or may there be something else influencing the result? So, have a look at the boxes on page 386 for the chi-squared test. In the top orange box, you have the results of a dihybrid cross, where there was the colour of the potato and also the way that it was cut. So it's either a cut or it's a potato, beg your pardon. So you've got 2 things. You've got a colour, it's either purple or green, and looking at the results there, the purple is obviously the dominant allele. The cut shape is the other dominant characteristic. So the plant is either purple or green, and it's either cut or potato. The results here show the number of individuals that were made by the cross. In this case, there was 144 of them. So in this particular cross, they're expecting a 9:3 to 3:1 ratio. And if you have 144 results, you work out the proportions by dividing the numbers just as you did in a previous problem. So the purple cut, you would expect to say 9/16. Remember, in the Punnett square for the dihybrid cross, there are 16 boxes, 4 by 4. So you'd expect 9 of them out of the 16 to show both dominant characteristics. So in that particular case, looking at that, you say 9 divided by 16 times 144, which was the number of individuals that were produced, which gives you 81. And you do the same for the 3:1 ratio, the 3 and the 3, showing only one of the dominant characters. So the second line shows the purple, which is the dominant character. You'd expect 3 out of every 16 to show that characteristic. So you say 3 divided by 16 times 144 is 27, and so on. So you see they've got the 9:3 to 3:1 ratio in small time over the 16s. 9/16, 3/16, 3/16, and 1/16. So that's the theoretical, that's what you would expect to find amongst those 144 individuals. 81 of them would be purple cut, 27 of them will be purple potato, 27 of them will be green cut, and 9 would be green potato. The reality, just like when you toss a coin, it's not always going to be exactly like that. And in this case, looking at the next little box down, there were 86 purple cut as opposed to the 81 that you expected. There were 26 purple potato compared to the 27 that you expect. There were 24 green cut as opposed to the 27 that you expected, and there were 8 green potato compared to the 9 that you expected. So the purpose of the chi-squared test is to compare what you expected to find with what you actually found. And that's what brings us to the formula at the bottom of the page. So looking at the formula, chi-squared, that squiggly x squared, equals the sum of, which is the sort of the zigzag pattern, of the observed minus expected result, all squared, divided by the expected result. And when you do a chi-squared test, you would fill in your results in exactly the same way as is shown at the chart at the bottom. So you had 4 possible different phenotypes that you were looking for: purple and cut, purple and potato, green and cut, and green and potato. So you've got 4 columns. In the first row, you write down the observed number out of your 144. So 86 purple cut, 26 purple potato, 24 green cut, etc. You expect, from your knowledge of genetics, to have a 9 to 3 to 3 to 1 ratio. So the expected number is the sums that were shown in the first purple box: 81, 27, 27, and 9. So now you do the formula. First of all, in the 4th row of numbers, you take the observed number minus the expected number. So the observed was 86, the expected was 9, it was 81, and so the difference between 86 and 81 is 5, and so on with the other 4 columns. Observed minus expected squared gives you a positive number, because if you look at the observed minus expected numbers, you've got -1, -3, and -1. Much easier just to have whole numbers. So you square your answers. So +5 squared is 25, -1 squared is 1, etc. And then for each of those, you divide it by the expected number. So 25 divided by the expected number, which is 81, gives you 0.31. The second column, the observed minus expected all squared, is 1, divided by the expected number, which was 27, so 1 divided by 27 is 0.04. And you do that for the other 2 columns. Add them all together, so 0.31 plus 0.04 plus 0.33 plus 0.11 gives you the sum at the bottom of the page, 0.79. And that is the answer to the chi-squared test. So you have an answer there of 0.79. So that is chi-squared. So what does that mean? That number you have to look up in a chart which will be provided for you. If you look on the top of page 387, there's a section of what is called a degrees of freedom chart. So how do you work out firstly the degrees of freedom, and which of those columns of figures are you going to look at? Well, very simply, the degrees of freedom is the number of different variations minus 1. Degrees of freedom equals the number of things that you're looking at. In our case, 4. Remember, there's 4 possibilities. There's 9 to 3 to 3 to 1. You've got 4 possibilities there. So the degrees of freedom this particular case, with a dihybrid cross where you've got the 4 different options, the degrees of freedom you look at is 3. And so in this particular case, we'd be looking at the 3rd line of numbers down, where it says degrees of freedom 3. Now the next question is, which column do you look at? And as a matter of course, we always look at the 0.05 probability column in all chi-squared tests. So now we look at the number that appears in the 0.05 column and the 3 degrees of freedom row, which is 7.82. And now the only other thing that we need to do is to say, how does that number in the chart, 7.82, compare to the number that you found, which was 0.79. So you're comparing the number in the chart with the number that you got. And very simply, if the number that you got is less than the number that's in the chart, it is not significant. It could have happened by chance. Just like when you toss a coin 100 times, if you get 52 heads and 48 tails, it happens by chance. If, on the other hand, the value that you got was larger than 7.82, then it means that there's something else at play. It can't have happened just by chance. So toss the coin 100 times and you get 80 heads and 20 tails. Now, if you got that, you would assume that there was a problem with the coin. There was a weight on one side to make it fall more often like that. So there's another factor coming in apart from chance. We don't worry about what the factor is at the moment, but at the moment all we're going to do is to say, was the result you got, 0.79, significant or not? Could it have happened by chance? Because your number is smaller than the one that appears in the chart, it happened by chance. If this had been a big number, bigger than that, it means that there must have been some other factor involved. Now that information should allow you to do the questions in the prep. And if you look at the question on page 387, what you've got there is a set of results. Those are the observed results. So you're going to need to add them all up to find out how many you had, and then put it into the little formulas like in the first orange box on the previous page. What you expected that's what you got. What you would have expected is a 9 to 3 to 3 to 1 ratio. So you have to add those numbers together, 54 plus 4 plus 4 plus 18, and work out how many you'd have got with 9 to 3 to 3 to 1. And then you can create a chart just like the bottom of page 386 with your results and decide by looking at the degrees of freedom chart at the top of page 387 whether or not it is significant. In an exam, these questions are far more limited. And if you look at page 396, part C of the question I've asked you to do, you'll see from the chart that already it's partly completed for you. Observed numbers are all there, ratio, expected numbers, some of the observed minus expecteds and observed minus expected all squared are already there. To get your marks, all you've got to do is fill in the gaps. Then you've got to calculate chi-squared, and then using the degrees of freedom chart at the bottom of the question, they've actually given it to you there. They aren't expecting you to pick out the line for the the degrees of freedom of 3. It's all there for you. Okay, I hope that helps.